Alright, I just want to finish up the last four problems that we didn't get a chance to go to in our pink packet on graphing linear inequalities. On the second page, we worked through the first four graphs. I want you to go there so we can look at the last four graphs. Number 5 is a y is less than or equal to 1, and a y equals is always going to be a horizontal line, and it's going to be a solid boundary line because of the less than or equals. And notice I'm not even writing down the slope or the y-intercept. It's going to, we need y is less than or equal to 1. I've got my solid line. I'm going to shade everything below it. The b would actually just be 1, and the m is 0. We don't have a rise over a run. It's a horizontal line. In number 6, it's y is greater than 3x. I just wrote y is greater than 3x plus 0 to point out that the y-intercept would be 0. The slope would be 3 over 1. From there, I do a rise of 3, run of 1. It is a straight up greater than, so I'm going to have a dashed boundary line. And since it read that y is greater than that, I'm going to shade above the line where I see y values that are bigger than that 0 y-intercept. Number 7, in order to graph number 7, the first thing I want to do is just add x to both sides, so I have it in a y equals mx plus b form. It's actually a y is greater than or equal to x plus 1. My b is going to be 1. My slope, or my m, is going to be 1. I'll treat it as 1 over 1. Start on the y-axis at 1, up 1, right 1, up 1, right 1. And it's going to be a solid boundary line because of the greater than or equal to. Draw my arrow, and I'm going to shade for values of y that are greater than. In number 8, similar to 7, I've got to get it as y alone. I'm going to subtract x from both sides and find out that y is greater than negative x plus 3. My y-intercept is going to be 3. My slope is negative 1. I'll write it as negative 1 over 1. Starting at 3 on the y-axis, down 1, right 1, down 1, right 1. I could follow that pattern. I'm going to have a dashed boundary line because it's strictly greater than. And then after I draw my dashed boundary line, I go back to dashed because of the greater than, the fact that it was y is greater than, so I want to shade for values of y that are greater than my y-intercept of 3. So there's the last 3 in your notes packet. Remember to use this to help you with the work you're doing.